Algebra 2, Chapter 9.2, Exercise 1 through 12. This set of exercises involves the parent inverse function of parent rational function. F of x equals 1 over x. And we're going to perform transformations of this function. There are two basic formats for that the book gives. One is the one that I prefer, which is f of x equals a. And a is your constant variation times 1 over quantity x minus h plus k. And this is the version that I actually prefer. But there's another version as well that takes this form, f of x equals 1. And down here in the denominator, instead of having a in the numerator, we have 1 over b in the denominator times quantity x minus h, and then outside here plus k. And h, well, a in the first function here, the one I prefer, is the constant variation. And this number a determines vertical stretch or compression of the function. And if that number has to be negative, it'll turn the graphic function upside down. And down here is f of x equals 1 over 1 over b. What I like to do is I always like to change this 1 over b to whatever it is. And the b would be indicative, if the b is greater than 1, it would be a horizontal stretch. But I like turning all into the a. And then h moves the graphical function left or right. X minus the value moves the function, graphical function to the right. X plus, which would be x minus negative, whatever it is, would move the graphic function to the left. And finally, outside we have plus k. And k is adjusts the transformation of the function up or down, depending on value k. And so we are asked to describe how the graph of g of x is related to the graph of f of x equals 1 over x. Well, here, in the place of k, and this is for 1 now, k is equal to 4. So what this means is that f of x is translated up 2 units. No, not 2 units, 4 units. I might get 2 from. I don't know. Straight up. That's it. Here's that one. Next, we have 3, g of x equals 1 over x plus 3. Well, according to the format, we had f of x is equal to a over x minus h, and outside plus k. Well, what we have here is g of x, rewriting this function, is equal to 1 over x minus -3. And the reason I write this way is because h has to equal to -3. And what that means is f of x is translated three units to the left. And this year, this is a constant theme for the horizontal translations of graphs of functions. X plus moves to the left, in this case x plus 3, and x minus would move to the right. Can you use other words besides translated? Yes, but maybe not exactly. Moves, slides. Next, other problem 5. G of x equals 1 over x minus 7. Well, again, in the format, f of x equals a multiplying x minus 8 plus k. You should be able to see that k takes the place of negative 7. So to translate f of x to become g of x, we'll say f of x is translated 7 units down. And these are also very easy to graph in your graphing calculator to see what they will do as a test of your understanding. Next odd new problem we're going to look at is 7. In this case, we have, I'm going to write the parent function again, we have a over quantity x minus 8 plus k. In this case, a is equal to negative 0.1, or in fractional form, I like that known as negative 1/10. So a couple different things are happening here. First, the negative sign. Negative sign is going to reflect the graph function about the x-axis. I'm actually going to do that in the calculator here too. I'm going to get up that calculator here. So here we are with our Smart View calculator. There we go. It's coming up. Let's go back here. Okay. Let's say for this one, f of x is reflected about the x-axis or across the x-axis. And we have 1/10, which is less than 1. And f of x is vertically compressed by a factor of 1/10. So let's go look in the calculator. I think I tried to get it up here. First of all, I'm going to put the okay. I'm going to put first the parent reciprocal function, which is going to be 1 over x, and just kind of see what that looks like. So that's what this looks like here. Now I'm going to go take what we have here. And we'll have just to be sure we're doing this. Negative 0.1 times 0.1 over x. So negative 0.1 times, we'll put 1 over x. It should be reflect about the x-axis and vertically compressed by a factor of 1/10. And it's kind of hard to see here. If we go ahead and take a little bit tighter view of it, change the window to negative 4, 4. Yeah, the red one's harder to see when you vertically compress and you really zoom in on what's going on. Let's take this. Yeah, so 1/10 of the amplitude and reflected about the x-axis. So that's what it is. Okay, next, no problem. 9, and here's a new set. Identify transformations of graph or effects of transformations that produce the graph of a given function g of x. Graph g of x and same coordinate planes graph of x by applying the transformation to the asymptotes x equals 0 and y equals 0 to reference points. Negative 1, comma negative 1, and 1, comma 1 also state the domain. Well, the domain is always going to be related to what the vertical asymptote is. And the vertical asymptote is going to be what you do, you say x plus 1 is equal to 0. And if we solve for x, x is equal to negative 1 is our vertical asymptote. So that's x equals negative 1. I just drew this vertical line there. And if we go ahead and put in a value of negative 1, it says to the reference points, negative 1, 1. So if we go ahead and put in g of negative 1, what are we going to get? Well, we're going to get 3 times 1 over negative 1 plus 1 squared minus 2. Well, what we're doing is we're moving over. That's going to put us right on that vertical asymptote. So what we have to do is we're taking this point, negative 1, comma negative 1, and we are shifting it to the left. Let me just put it down this way. Okay, let's see. The f of x, this reference to f of x, is translated. We have x plus 1, so we have 1 unit to the left, and 2 units down. This k is minus 2. And so if we translate this negative 1, comma negative 1, we go 1 unit to the left and 2 down. So what we have is two reference points saying negative 1, comma negative 1 translates to -2, comma, -3. And then likewise, yeah, it's going to be more than that though because of that's a temporary. And then we have this point here at 1, comma 1 goes to the right, or goes to the left 1, to the left 1, down 2. So we have 0, comma, -1. But that's not all there is to it because we have this a value of 3. So what we have to do is uh, also f of x is vertically stretched by a factor of 3. And so what happens is these relocated points here are going to be, you have to go ahead and if we vertically stretch, we're going to move this one up from 1, 1, 2, 3. So we really have to reflect this point here as well. So we bring this point to the left 2, left 1 and down 2. So we go to 0, comma 1. And then this one below, you have to take down because the vertical, the horizontal asymptote is be right here. And we have to take this one down 2 more units. So we go -2, comma, -5. And so we're going to have something that looks like this. I'm going to hit this point down here. And we're going to hit this point up here at yeah, 0, 1. And go like this. So that's what it's going to look like. And domain. So using inequality, set notation, notation. But this is going to be a verbal description of what's going on. Our domain is going to be, it says they're using inequalities. So we are going to be, x is greater than -infinity. Let me write it different ways. We'll put it -infinity is less than x, which is less than our positional vertical asymptote, which is -1, and also x is greater than -1, and less than infinity. So that would be our domain, and our range is going to be same type of process, but with y up to our point horizontal asymptote of -2. So we go from -infinity is less than y, which is less than -2, comma, -2 is less than y, which is less than infinity. So that would be in our quantum notation. Set notation, I'll just put D, is going to be x such that x is element of all real numbers, and then x cannot equal, if x cannot equal -1. So that would be an example of a domain. Range, very similar. Range y such that y is an element of all real numbers, except y cannot equal -2. And finally, interval notation, domain greater than -infinity up to including -1. And we're going to put union here, greater than -1, less than infinity. And our range is going to be very similar, except we're going to have -2 as a critical number here. U, -2, comma, infinity. So this is going to be our domain and range. And inequality, set, and interval notation. See, did I do anything? Did I miss anything else in here? Yeah, we graph on the same coordinate plane. That's pretty much what it looks like. Okay, let's go on to our last one we're going to do in this exercise set, which is 11. And we have A is equal to -1/2. What we're going to do is take, we have x minus 1. So our vertical asymptote is going to occur here at x equals 1. So for this we have a -1, comma -1. And then as far as our horizontal asymptote, we have y equals -2. So y equals -2, x equals 1. So we can see our asymptotes here already. The point -1, comma 1, we went to the right 1. So we'll say f of x is translated right 1 unit and down 2 units. And then, so this point, -1, -1, goes to the right. So we add 1 to -1. So we get 0. And then we subtract 2 from -1. So we get 0, -3. Next, put this below. We have 1, 1. It's translated. We add 1 to 1, we get 2. We subtract 2 from 1, we get -1. And we're still going to, one thing we could do also is we could just plug in 0 and -2, see what we get. That's a strategy on this. But we are turning these, we're compressing the negative sign. F of x is reflected about the x-axis. And vertically compressed by a factor of 1/2. So we're going to take this, and what we're reflecting it about is kind of a new x-axis. So we move this point over here, and 1 to the right, and down 2, right, 2, -1. This other one we took to the right and down 2 here, so we get 0, -3. What we did is we're reflecting this point about the x-axis, and then we are compressing by a factor of 1/2. So we're going to get, you have to go from -3 to -1 down 1/2. So we're going to get 0, and we're going to get -3/2 for this -1, -1. So 1, 1, we come over here, and then we reflect about the x-axis to get 2, -3, but then we're going to go up 1 to right here. So that's going to be -2.5 or -5/2. We get 2 and a -5/2. So now that helps us really to sketch, because instead of going up here like this, we reflected it down below, reflected it up here, so we get this type of graph here on the left side of this vertical asymptote, and on the right side, it'll come up like this. You can see that that's inverse equation. So what is our, it's going to be the description of the of the transformation. Now, as far as domain, first of all, in a qualification, we have negative infinity is less than x. We have vertical asymptote at x equals 1. Okay, and then we have 1, or x is greater than 1, but less than infinity. And our range, looking right, is going to be negative infinity is less than y, which is less than our horizontal asymptote of y equals negative 2. And then y is greater than negative 2, but less than infinity. Now for our set notation, x such that x is element of all real numbers, but x cannot be equal to 1. Our range is going to be somebody says y such that y is an element of all real numbers except y cannot equal the value of the horizontal asymptote, which is negative 2. And then finally, in interval notation, we have domain, negative infinity, comma 1, union, 1, comma infinity. Our range is going to be greater than negative 3 to less than negative 2, union, greater than negative 2 to less than infinity. So there we have our domain and range, and inequality, set, and interval notation. And here's number 12, you can see what that is. Anyway, here's some exercises. I hope it helped you. Good luck. And thanks for doing it.